All right, let's get started. My name is Jacob Rossi. If you were here earlier for the W3C panel, welcome back. I'm a program manager for Internet Explorer. I work on web standards. I've worked on a lot of different things over the last few years, and lately I find myself spending a lot of time with touch and other input modalities for the web, and thinking about how we can take the web into the next generation of interaction experiences. And so I'm going to talk about a few different technologies that are here today and emerging for you to use to build new experiences that you couldn't build before on the web. So I showed a slide like this earlier to sort of sell home the point that when we started looking at modern input for the web, we thought about where we thought devices were going to go and where we wanted that to go. And it turns out our predictions were very, very true. You see a very diverse model of devices out there today. And even different from just a year or 2 years ago. And I'm not talking about necessarily speed or how thin or how long your battery life is. I'm talking about the form factors. You have phones all different kinds of sizes. You have phones with pens. You have laptops with touch screens. You have Chromebooks with trackpads and a touch screen. You have large TV screens that can support the web, tablets of many different sizes. So how you design your sites and applications in terms of your layout, presentation, UI, and input is really evolving. And this can be a daunting thing for a web developer, and it can be tempting to just design for the least common denominator. All my UI is going to be click event based, and that works everywhere. And point and click used to be that phrase that we described software with to say it was intuitive, it was easy, it was an attractive thing. And it's kind of old-fashioned now. That's not what users want to do. They want to immerse themselves. They want it to feel physical. They just spent hundreds of dollars on this brand new device, and they want to use it and to its fullest potential. And point and click gets the job done, and sometimes it's the right thing. But there's a lot more immersive and fun experiences that when users have that as their interaction paradigm, they actually spend more time on your site and they come back more often because it's subconsciously kind of fun. And so when we thought about for our own products how we would approach, and particularly touch, we came up with a lot of principles around how we designed what we call our interaction language. And one of those key components we call direct manipulation. And so the reality is, on a touch screen, the user is sliding their fingers across glass, but your job as a web developer and our job as browser implementers is to make it feel like they're moving the web page. Forget that the glass is there, that there's just light emitting from behind it. Feel like it's more physical and natural for the user. And this is accomplished through keeping in mind a few basic tenets. So first, your UI needs to react instantly. Most things in the real world, when you touch them, they do something. And that's really important. That's both how you design, for example, providing feedback on down versus on up. And also, just in terms of a performance exercise, you're making sure that you can provide that visual feedback right away to the user. So instantaneous response is important. For touch, sticking to your finger is critical, and that means 60 frames a second. Use your browser tools to figure out what your bottlenecks are so that it can stay up close to your finger, and keep it natural. So a thing I see in a lot of apps and sites that doesn't follow this principle is notions of sort of one-off gestures, things like a swipe. On swipe, I play this animation and turn the page. That's not how a book works. That's not very fun. I start to slide my finger. It's not intuitive. I don't see a reaction right away. It should slide with me. And so if your gesture handling isn't ongoing, then it isn't direct manipulation. Another common problem that I see, and this is particularly interesting for the web, for sites specifically, is that we've been given this new tool and we're using it in lots and lots and lots of crazy different ways. And one unique perspective that we took on our interaction language is keeping it simple. We have a very limited number of what we call commanding vocabulary for how you interact. I tap, I hold, I slide my finger, I pinch it, I rotate, just a few different phrases. And we try to avoid things like, well, one finger swipe does this, two finger swipe does that, three finger swipe does that, and if you five finger slap your tablet, it will turn off. It's interesting and it's fun, and actually it can be a challenge. I've got 20 different things that my app can do, and I need a gesture for each one of those. That's very tempting to be creative and use lots of different things. But when you think about the web, there's trillions of web pages. If everyone used a different interaction model, a complex interaction model, it becomes this like secret handshake that you have to know to unlock the features of the web page, or perhaps they never discover it at all, or you waste valuable UI space in explaining on this site if you use three fingers to do. And so if you keep it simple, users are going to discover it and find it easier, and as they go from one web page to another, there's not this massive context switch that they have to go through. So one of the easiest ways that you can take advantage of direct manipulation and these principles that I'm talking about is to leverage native panning and zooming in the browser. We spent over 3 years investing in re-architecting how Internet Explorer and Windows web apps pan and zoom. And now I'm happy to say we have a pretty amazing experience, industry leading. It's a pan on a web page will react in less than 50 milliseconds. And that's even true if your JavaScript is spinning in a while true loop. Because we took advantage of the GPU, we took advantage of multiple threads, we designed our APIs to be cognizant of the needs for apps to have to be able to have native-like performance. So get creative with it. We think a lot of times of panning and zooming as the way to move through a document. The web's kind of gone through this phase where it was originally mostly documents, lots and lots of documents linked together. And so panning and zooming are the way that I can get to the bottom of the document as I read, and zooming lets me look at the thing that I can't see as clearly. But there's actually lots of other ways that you can use that, especially with modern APIs available in browsers today. So just an example to get your mind spinning, I built this color picker here. This is pretty simple actually. It's a horizontal scrolling region, and on top of it, I've overlaid just a translucent div, and with a little slit in the middle to indicate what color you're picking, and I can slide it back and forth and use the scroll offset to figure out what color you're using. Or if this was a canvas, I could just query for the actual pixel. And so I'm using the CSS pointer events property to take those transparent divs on top and disable hit testing so that when I touch them, the touch actually goes through and scrolls the scroller that's underneath it. This is not to be confused with the pointer events for JavaScript I'm going to talk about in a minute, but if you haven't discovered CSS pointer events, go check it out. It's actually a pretty powerful API, and we support it in IE. So we thought we can really leverage this hardware accelerated panning and zooming to its fullest potential if we give you APIs that let you customize it and personalize it to new experiences. So I'm actually happy to announce that today Microsoft submitted a spec proposal to the CSS working group for new APIs that we call scrolling snap points. This is one of many ways that we're trying to improve touch and other input devices on the web. And the basic concept is it's a common user experience paradigm to build paginated content or say a photo gallery, things that I want to swipe through. You've got a linear list of things. It's easier to pan through it than it is to click a next button, next. And so snap points help solve the problem of imprecise input. And what I mean by that is that with touch, it's actually hard to guarantee a consistent scrolling experience. Say you want it to always show just a single page at a time. And so with 2 lines of CSS that I've used here, what I've done is I've taken this scroller. I've got a visual here. This is the contents of a scrolling region. I've got a bunch of images lined up next to each other. And I've set up snap points in this scroller. And these snap points are places that whenever the user scrolls, the browser needs to make sure that the scrolling lands on one of these edges. So in this case, I've used a snap interval. So I said, starting at 0 pixels, so the left edge, since this is the snap points X API in a left to right document, and repeat every 100% width of the containing block. So my scroller in this example would be, say, 500 pixels wide. Since every one of my images is also 500 pixels wide, and I've set up snap points every 500 pixels, I produce an experience that looks like this. So I have an image here, and I can actually swipe through them, and it's sticking to my finger. It's running at 60 frames a second, less than 50 milliseconds response time. And even if I let go in the middle, it's going to make sure that it goes to the edge. And you're getting all this awesome inertia scrolling and bounce and all the things that would have taken you hundreds of lines to write in JavaScript, and it would have been way slower. Looking back again at the API here, a couple more notes. So this was an interval. I just want to set up a regular set of snap points. There's another syntax called snap list that just lets you give a discrete list of points arbitrarily. And also there's this snap type API here. This one lets you say, there's 2 values right now, and there's mandatory or proximity. Mandatory is whenever scrolling happens, you must snap at one of these snap points. Proximity is fix it up if it's close. And you can build lots of different experiences. Proximity might be used, for example, in a list of thumbnails. If you might set up proximity snap points in the middle of the images so that when you're scrolling along, you're always clipping an image at the edge so as to give the indication that there's more that way. So things like that make this API actually really powerful. And so we're looking forward to working with the W3C on standardizing this and that being a means for interoperability. Oh, and by the way, in case you hadn't realized, this is all running in the browser using Flexbox and snap points. So back to that using panning and zooming creatively. Now with snap points and panning, let's think about interesting UI that I can build. So it's not just about photo galleries I can swipe through. Here I've built a pull-down menu that I can swipe from the top and bring back up. So this is building on the trick that I used in the color picker. So what I actually have here is a scroller that overlaps this entire page. And I've set up snap points in this scroller at the white line above my finger and at the top of the menu. So there's only 2 snap points here, and it's mandatory, so it either has to end here or it has to end here. And then in the region below the menu, I've used, again, the CSS pointer events property to disable hit testing so I can go through and click things underneath. Again, this was probably not just the snap points, all of the CSS, maybe 10 lines and an equal number of lines of HTML, and that would take a lot of JavaScript to build a less rich experience. So moving to a different kind of pointer events. I talked about the expansion of device input modalities on the web. And I talked earlier about how we conceived of a new API called pointer events. You're probably familiar with touch events. And when we were looking at devices and we thought about how they were changing and adapting to have lots of different input types together, we saw a common problem. We saw a lot of code that was going, if touch event, register for a touch move handler, else register for a mouse move handler. So when I grab my Surface with a trackpad, or I plug a mouse in, or I have my Pixel, and I go to one of these sites and it says, you have touch, I'll register for touch, but I won't register for mouse, and now you can't use it. So that wasn't a good way forward. And we're going to rinse and repeat this problem if we just kept creating a new input model for every device that came along. So we designed pointer events as a way to abstract this concept: a mouse, a finger on the screen, a pen tip, maybe connect in the future, leap motion, camera sensors. You can go on and think of lots of different examples into a single entity called a pointer. So, and we also designed them to have the simplicity of mouse events, which you won't necessarily find with touch events. So you can actually migrate your code fairly simply, and I'll show that in a minute. And it uses a lot of the same practices you can find from, or APIs and things that you can find from mouse events. But it supports lots of different device types, including multi-touch or multi-user is a conversation we've been having in the working group. If you think about Wii remotes, for example, multiple people using them at once, really neat applications that you can think of there. And it has device-specific properties that, like pressure or your touch contact size and that kind of thing, that when you're on a device that doesn't support those things, those properties are actually emulated as best as possible. So you already know the basics. You're not really learning a tremendously new thing here. If you've used mouse events like most web developers have, it looks really familiar. There's down, there's up, move, over, out, enter and leave. There's this new one called cancel. If you use touch events, you're kind of familiar with what a cancel means, but not just for touch. There are scenarios in which the input is no longer valid. For example, your touchscreen might support 5 points of touch, and I come in with a 6 finger and say, aha. Well, if it can only support 5, one of those has to get canceled, and then you'll continue getting pointer events for the rest. So in a lot of ways, you can often treat cancel like you would up, other than to say commit to an action. So you're not going to click a button on a cancel because that touch isn't valid. It's not necessarily come up. So if you have mouse event, so I talked about being able to differentiate. So there's the pointer type property. And you can go and do device-specific work. So it's device-independent when you want it. You can share code across the devices, but it also lets you be device-specific when you need it or want to light up a particular device in a certain way. And this just gives you kind of a basic example of how you can do that. I encourage you to try and provide the default case, the else case for a generic pointer that might come along the way in the future, so that you can provide some basic support for your users. So let's walk through an example. So this is just a basic canvas drawing application. What I'm doing is I'm using mouse events, just down and move. And when you move, I'm keeping track of the last 2 points and just drawing lines between them. It's pretty straightforward. So let's look at trying to move this over to using pointer events. So step 1, actually this is just a basic demo of the code here, so obviously I can draw with my mouse. So step 1, let's swap out the mouse events for pointer events. I'm literally just replacing them. Mouse down went to pointer down, mouse move went to pointer move. Let's try that out. No other code changes in my demo, and my mouse just kept working. So no regressions, happy developer. So let's try touch. Uh-oh. Well, why didn't touch work? So this was one of the learning experiences we had along the way with designing pointer events. In an early preview of IE10, we followed a model that's been used in events for years. You call a method like prevent default and say, don't do your default action, I've got it, browser, I'm going to do my own thing. And so that was the way in the first iteration of just a preview release that you would prevent panning or zooming. Well, the problem with that is that you have to go run the JavaScript code to find out if you should pan or zoom as a browser, you the browser. And you might go calculate digits of pi or run some other thing, logic, whatever that you have to do, and that can take valuable time and break down that illusion if we do end up panning of direct manipulation. You're going to stutter. You're going to move your finger, and then it's going to catch up later once you're done running your JavaScript code. Because, by the way, your JavaScript code is in competition with a whole bunch of other work that's being done on that same thread, because that's how browsers have historically worked. And we thought, browsers don't need to, in fact, can't keep working on just a single thread going forward. We need to be able to do this stuff on multiple threads. We need to be able to do this stuff on the GPU in order to bring the web platform closer and closer to those native-like experiences. So we got rid of that capability based on developer feedback and the experiences we were seeing, and we instead replaced it with a new CSS API called Touch Action. And this is perhaps one of the most impactful, yet subtle sometimes to developers, piece of pointer events because of the performance implications. So its default value is auto, and what the property means is I'm telling you what touch behaviors like panning or zooming the browser can do. So auto being you decide, and most of the time in modern browsers, the default action for touch is going to be to pan or zoom the page if I slide my fingers across the screen. But when you're using pointer events, the common value, or a common value, is none, saying don't pan or zoom, don't perform a touch action. I want the pointer events for this behavior, and I'm going to handle it. There's other configurations that you can combine in here. Pan X being only enable panning on the X-axis, pan Y being in the Y-axis. IE supports some additional gesture-specific properties like pinch zoom or double tap zoom, so that you can configure these things. Neat tip, by the way, who's familiar with the 300 millisecond tap delay for a click? Yeah, if you use touch action to disable double tap zoom, just touch action none, for example, that goes away in IE. So that's a really valuable. No need to bring in libraries and things like that. So it's a nice quick trip, one line of CSS. So if you have touch actions enabled or it's auto, and the browser decides that a touch action should happen, you're notified of this through pointer cancel. So this is another way that the pointer cancel event can fire. So for example, I might touch the web page and get a pointer down, slide my finger, the browser says I'm going to pan, and so you get a pointer cancel event. And so that's another reason why you want to make sure you take that event into account. So thinking back to our demo here, we're going to swap out, or we're going to add into our CSS a touch action rule in the canvas element to say touch action none, give me the pointer events. So checking back to our mouse, things are still working just fine. And now when I bring my finger in, it works great. In fact, I'll step over here. And it works for pen. So all I did was two things. I swapped mouse events for pointer events, and I threw a touch action rule on it to handle touch. And now it's working for a variety of different input devices. This is easy work, actually. There's one more gotcha. Let's try multi-touch. Oops. So what's happening here? Well, my mouse event code had this nice simplicity of expecting there only to be one point moving across the screen at once. And so what's happening is I'm getting pointer remove events for both of my fingers as I drag them across the screen. And my code is drawing a line in between each finger, back and forth as I slide them across the screen. Obviously, that's not what we want. So let's look at how we handle multi-touch. So pointer events provide a pointer ID property, and this is going to give you a unique identifier. It's just a number to differentiate one pointer from another. That includes whether it's a mouse, a pen, a finger, etc. So I'm going to take my code here and modify it. And now instead of just storing the last 2 points, I'm going to change that array into a two-dimensional array, and I'll index that by the pointer ID. So I can go access my pointers array by the pointer ID I'm handling at the time and retrieve back an array of the last 2 points for that pointer. Now that I've got multiple arrays going on here and the pointer IDs continually change as I add new fingers to the screen, I also need to make sure that I'm deleting those out so I don't just grow this array infinitely large. So this wasn't too complicated of a change, and now I can see that multi-touch works, and of course, mouse and pen do as well. So far, we haven't done anything specific for any kind of device, and I'm actually not going to here, but I'm going to talk about device properties that pointer events surface up that mouse events don't. So width and height. Today, these are primarily touch properties. Higher-end touch hardware, Surface, for example, provides actual geometry of your finger, the width and the height of it on the screen. That's incredibly powerful. You could imagine how I could turn this into a real finger painting application using that. You can get pressure. Today, this is primarily a pen property, how hard I push down on this digitizer. But you can imagine how that can be, touch sensors are actually capable of being improved to handle pressure as well. And tilt being something that you think of primarily for a pen, and I'm going to give you a little demo of that in a second. But also, you can imagine tilt being how I orient my finger on the screen. So that's a pretty powerful piece of information. You might, for example, infer handedness to adapt your UI not to be occluded. There's some really, really creative out-of-the-box ways you can start to use this stuff. And there's already talk for a version 2 of pointer events that will add even more information as devices get better. So one of the things that we did as we worked with the W3C and JavaScript frameworks, web developers, and other browsers was one of the feedback was these needed not be device specific. So when a device doesn't support these things, the spec now says that you should emulate them. And an example of that is pressure for mouse can be emulated based on the button state. You can increase the pressure as buttons are pressed, things like that. And so we do that kind of emulation so that you can code interoperably no matter what device the user happens to find themselves using the web at the moment. Width and height, for example, come into play even on touchscreens, because sometimes touchscreens don't support that. So why don't you supply a value that's about the size of a typical finger? And then that's what we do. And so we updated IE11 to support all these things and match the candidate recommendation spec. And another note is that we removed prefixes now that we're in candidate recommendation. So it's becoming a mature API. So let's see how we could use one of these properties. I've used pressure here, and I'm taking pressure which varies from 0 to 1, 1 being roughly the maximum pressure that you expect from the device, 0 being no pressure at all. And I've multiplied it by 10 and used that as my width in my stroke. So, also, I used the pointer ID. I modded it by the length of an array of colors so that I can pick a unique color for each pointer on the screen so you can differentiate it a little better. So you can see that with touch. I get 3 different colors. Let's flip over to the pen here for a second. And so what you can see there is I can dynamically press harder and adjust the pressure with the pen stylus, and the pointer events provide that information, and I can provide realistic stroke widths to make a better drawing experience. This, by the way, is a Wacom Intuos tablet that is used by a lot of graphic designers. So I have another cool demo to show you. In fact, it's actually just the same demo. And this is the first time this is being shown, so this is pretty cool. This is the one and only time you'll see me do this. Choose Firefox here as my default. So this is an early build of Firefox supporting pointer events. This is roughly the same code. I've made a few modifications to work around a couple bugs we're still figuring out. But it works with multi-touch and even my mouse as well. So this is pretty cool stuff. And we're happy to be working with the guys at Mozilla on this. There's a subsidiary of Microsoft called Microsoft Open Technologies, and they specialize in interoperability and open source. And so they're actually working with Mozilla on the implementation of this. They're also working with the Blink community and WebKit communities on support there. So we're hoping that we'll see support in builds in Firefox fairly soon, and Chrome maybe down the road. So let me switch back to a modern browser. Snark. And I just want to show you one more cool demo with how you can use these properties from devices. So this is using tilt. This is mostly available on higher end pens today, but I think it's something that we'll see more and more of as we go forward. And like I said, we can do work to make this possible for other input modalities as well. So I can't take the mic over here, so just imagine me talking, or enjoy the silence. You get the idea, but it's pretty cool. This is just 3D transforms. I've got a pen. The tablet's picking up its position in space as I manipulate it in the air. And that's really cool. You can, like this tablet's pretty advanced. It actually has lots of different tips that you can use to simulate the feel of other drawing apparatus. And you can imagine how you can use tilt and pressure to provide a realistic drawing experience. You can, again, don't just limit yourself to the obvious. Think about things like UI. Perhaps I could build a radial menu that I could actually rotate my pen through to pick an item. There's lots and lots of possibilities here using this information from the hardware. So where can you use pointer events? We introduced the first support in IE10, prefixed as MS pointer event. And we unprefixed it recently in IE11. And as I showed, there's work in progress in Firefox and Chromium, and also jQuery. There are polyfills, though, that you can use everywhere. Hand.js or the Google Polymer project has an excellent pointer event polyfill. There's also Cordova PhoneGap plugins and work for Dojo and other frameworks that are coming online. So it's actually in use on a lot of websites today: Bing Maps, Google Maps, Flipboard, Contrajour, Pulse. There's a lot of real production sites using this today, so you can too. So they give you raw access to the hardware, and it's up to you to use that and interpret it. So I kind of want to show you another technology called gesture events. And this is something that is still emerging and something that we're thinking about how to make problems for developers easier to solve. So we have a new API called MS Gesture that is a way for the browser to help you process pointer input and give you gesture data. And in the same theme as pointer and zoom, panning and zooming or pointer events, we designed this actually to work across input devices as well. So you can actually recognize mouse gestures, pen gestures, touch gestures, etc. And it's a pretty powerful API. I'll walk you through how it works. Unlike other proposals on how to do gestures, the browser doesn't just automatically decide what gesture you're doing and fire events. You actually have these gesture recognizing objects that you configure, which impact how the gestures are reported to you. So the first step in using this is just to new up a new gesture object. So I just call the constructor new MS gesture. Second step is to assign that gesture recognizer an element. This is the element I'm recognizing gestures for. And the interesting thing is this has nothing to do with hit testing. It has nothing to do with deciding what fingers or what mouse is used in the gesture. It is to do with what you're going to apply the gesture to. So it sets up the coordinate system, for example, for the gestures. If you're using transforms on the element, then if you slide the finger to the right, you want that to be in the coordinate space of the element so that you can apply it to the element. And that's what the target assignment does. The third step is you listen to pointer events and tell the gesture object which pointers it should track. So you call an add pointer method during, say, pointer down, and you provide it the pointer ID of a pointer you want it to track. So this is the most basic case here. I've just listened to pointer down and provided the pointer ID for that pointer to the gesture recognizer. So now that it has a target element and it's got at least one pointer that it's tracking, it's going to start firing gesture events based on its interpretation of the pointer. So you listen to those through a variety of different events. There are some one-off events like MS gesture tap or MS gesture hold, but perhaps one of the most powerful is MS gesture change. And this is kind of like a move event in that it fires over and over as you continually perform the interaction. And again, this goes back to if you aren't handling your gestures ongoing, then you're not building a direct manipulation experience. And so this is built to let you provide direct manipulation through JavaScript when panning and zooming aren't as expressive enough for you. So let's look at what a gesture event gives you. So this is these are some of the properties that are available on a gesture event. Rotation, this is simply if I'm rotating my fingers, how many radians I've rotated it since the last gesture event, about the center of the gesture. Keeping with that theme of what you can do with one finger, you should be able to do with 2, 3, 4. Rotation applies no matter how many fingers I want to build or use. So, if I'm building an Etch-a-Sketch, I can turn the knob with 5 fingers or I can turn the knob with 2. And scale, this is primarily done by, I try to avoid pinch here because, again, I might be doing this, and that's not exactly a pinch, it's more of a grab. So scale factor is just a scalar multiplier, where 1 being, when you start out, as I grow my fingers, it increases above 1. As I shrink my fingers, it goes below 1. Translation X and translation Y, these are just movement linearly as I slide my fingers to the left and to the right and up and down. Likewise, I get velocity data, which is instantaneous velocity of how I'm moving my fingers. What's really cool is I actually get velocity in other forms too. I get angular velocity. How fast am I rotating? I get expansion velocity. How fast am I expanding my fingers? If you wanted to build some magic poof gesture or something like that, you could actually recognize this by using a velocity threshold. And all these values are delta since the last event, and that's useful, and I'll show you in a second. So this is a basic example of how to manipulate an element. So I'm combining here MS gesture and CSS transforms. So I'm listening to that gesture change event, and this implies I've already done the steps to configure a gesture object that I showed before. And I'm going to call the manipulate element function every time that gesture changes. So the first step I'm going to do is go grab the current transform from the element. In this example, I'm using the CSS matrix object, which is just a utility class that lets you perform basic matrix operations without having to go do remedial linear algebra. So it's pretty useful. You can also go grab your favorite matrix math library and do the same effect. And so I'm going to update the styles on the element, the transform on the element, based on the gesture data. Now, these next steps are actually important specifically in the ordering, and I'll leave that to an exercise for the reader on why that's important in terms of linear algebra. But if you kind of just memorize this algorithm, this is how you basically design a direct manipulation of an object in a page. And you can comment out individual pieces of this if you don't want to apply a particular transformation. So the first step is that my element has an origin for its transform, the transform origin property. And my gesture has an origin, which is generally the centroid of the pointers involved in that gesture. And in order to apply the transform that's happening with the gesture to the transform that's happening on the element, I need them to use the same origin. So step one is actually to temporarily translate the element to the origin of the gesture. So I'm using the offset coordinates. That provides the offset from the element's origin to the centroid of the gesture. So I do that, calling the translate method on the CSS matrix. And then next, I'm just going to utilize the rotation, scale, and translation data to apply those transforms. So I converted to degrees since that's what I'm using here in CSS transforms, and then I applied the scale factor and the X and Y translation. And once I'm done applying those things, now I'm ready to just undo that offset I did at the beginning. So I just apply a negative translate. So the steps are move the transform origin to the gesture origin, rotate, scale, translate, and then move the origin back. And in case I see a couple of people typing, this code I have a link to GitHub at the end of this where you can grab this code. So let's take a look at what that looks like. So here I've got a div that has this code running behind it. And I can drag this guy around my finger, and I can expand it and stretch it. And you'll see it's changing colors. That's to demonstrate that I can use MS gesture and pointer events at the same time. So I'm just listening to pointer events and applying transitions to change the background color as I manipulate it. I've also got another div over here, and that's to show you one of the really powerful things that you can do with MS gesture that you can't do with other gesture proposals is you can have more than one, and I can assign one set of pointers to one, and I can assign one set of pointers to another, so that I can actually build an experience where I can manipulate multiple things at once on my machine. And just to see a little bit more well-polished example, this was an app from the tabletop Surface, not the tablet variety, the big one. This was an app for doing a photo collage, and this is even the same images actually we got from them. And so here I can drag out a bunch of images. There's different categories, and I can manipulate this scary guy there and slide him around on the screen. This is on ietestdrive.com if you want to play around with that and see the code. So I always have to make sure I include this slide. There's a few special considerations for touch you should take into your site. And that's because it's a less precise input device, and most touch hardware today is limited in things like hover. So these will go a long way to making sure your site's compatible for touch input. Using 40 pixels or larger for your hit targets. Modern browsers will scale CSS pixels for device resolutions and things like that. So generally speaking, if you use 40 pixels, you're going to have a good size target for the size of your finger. Avoiding hover menus is critical. Almost all touch hardware today can't recognize your finger above the screen. So while a mouse can point at something without clicking it, a finger can't. And so there's hover menus all over the web. IE11, we introduced support for simulating mouse hover through touch. You can press and hold on something, and we'll simulate hover to enable menus because they're just everywhere. But if you provide an experience that's designed with touch in mind, it's going to be a lot more intuitive and fit better into your UX. Don't assume that touch means there isn't a mouse or isn't some other form of input. Don't assume touch is mobile only. I think this is starting to become pretty obvious, but there's a lot of code out there that only wires up touch support or a touch experience if you have, say, a mobile user agent string. But there are lots of devices, 2-in-1s, laptops with touch screens, Chromebook Pixels, etc. Even you see on the news people have these gigantic TVs that have touch screens and whatnot. So don't assume touch is mobile only. Feature detect, that's always a good tip. And lastly, use specific HTML5 input types. This is easy. Instead of text, when you can, use things like number or email or URL or telephone tel. And that's because on a touch device, a lot of modern browsers will provide an on-screen keyboard that's adapted for the kind of input you expect them to give. So you get an @ or a .com button if you're typing an email address, for example. These are all actually pretty simple things to go implement in your site, and they make a big difference and affect a large amount of users. So with that, I'm going to leave you with a bunch of links here. I've got the pointer event spec, the snap points proposal. There's a link here to a nice white paper that talks a little bit more about the design language for how we thought about touch interaction on Windows. There's a pointer events tutorial, if you will, that's on webplatform.org. And that's an excellent walkthrough, goes a little bit deeper than what I've shown here, gives you more examples. And finally, I've got my GitHub there. Most of the examples you saw today are there. If they're missing, just check back tomorrow and I'll have the updated versions on there later. You can follow me on Twitter, and if we have a few extra minutes, I can take some questions since I know most of the stuff is new for folks. There's 2 mics here.
Hey, how do you envision 3-dimensional input like leap motion integrating? Like, do you guess what some of the gestures are, and where's the barrier between what they have to provide and what the browser would do?
That's a great question. I had the pleasure of being in the Leap Motion developer program, so I've spent some time kind of playing around with this. I wrote a cool JavaScript library that I think is also on my GitHub that sets up a WebSocket server and pipes in the Leap Motion input. Today, like what I've experimented with is 2D input, so just mapping, not taking into account 3D. 3D has come up in the working group, and it's something that we're looking forward to tackling in 2D. It's interesting as you think about this device abstraction, agnostic input model that we have for pointer events. We have to figure out how to rationalize leap motion in 3D versus connect in 3D. What are the units? Is it feet, meters, pixels, some arbitrary range? So that's a discussion that we have to have. It's a tough problem, but I think it's one we're looking forward to talking about further.
How can you create a customer gesture and then let other people use it?
I'm sorry?
Create a customized gesture so other people can use it, like a library or whatever.
So there are libraries out there. One that comes to mind is called Deep Tissue that uses MS Gesture and builds on that to provide things like thresholds for recognizing a certain kind of gesture in their app. Like the poof example I gave was silly, but one kind of idea. And if MS Gesture doesn't do it for you, there's always pointer events that give you access to the raw data. But when you can, using a native support for gestures is better. It's actually really tough to build high-quality gestures. There's lots of gotchas you might not think about. For example, taps. If I wiggle my finger around and release it at the same spot, is that a tap? There's lots of different interesting things like that you have to take into account. Yes?
So I wanted to know more about the snap point API. I'm super stoked about that. Like, I don't have to write any more like the slider code that bloats my page. I wanted to know what are the browsers that are supported for that, and sort of what's the status of the spec? Is that accepted? Is that just Microsoft driving it?
So it is hot off the presses. It is a spec proposal as of like late last night. Yeah, it's very emerging. It was introduced in 9010, and we spent some time taking into developer feedback. It was originally a touch API, but scrolling is not just a touch thing, and the developer feedback was great. You saved me all this time for touch, but I still got to go write the hundreds of lines of JavaScript anyway because I got to deal with the mouse wheel and other things. So in IE11, we experimented some more with it and improved it to support mouse wheels, trackpads, keyboard, that kind of thing. And so now we felt like we had something that was worthy of being interoperable. And so that's the goal that we have with proposing the standard, and we're looking forward to the discussion there. It's vendor prefix now, and we should expect it to change. As we get feedback from developers and other browsers. You can use it though in IE 10 and 11 today.
Okay, including on mobile IE? Or?
I believe actually mobile has not yet supported it, and I think that's a goal for us long term. Yeah.
Jacob, can this be applied on the accelerometer, like no touch gesture also, the MS gesture? Like if I have a wearable.
I see. MS gesture does not.
Taking in the accelerometer data points.
So you'll device motion APIs, which are also supported in IE11, will give you access to the accelerometer, but MS Gesture today doesn't use that, primarily because we're not sure exactly what the input model yet should be for that. You think about, there's not a pointer, there's not a center of a gesture when I'm moving the machine, but that's an interesting consideration to make. The question was, would it be another API? Yeah, there is another standard out there that has device motion that gives you accelerometer data, and that's supported in IE.
Does MS Gesture support the Creative Lab device, and also does it recognize the finger position? For example, if I say 1, 2, 3, 4, does it recognize it? If it doesn't, because there may be various things to show you 3, right? Some people may do this or whatever. Does it MS Gesture support all that recognition so that you can figure out how many finger is being raised and all that stuff?
So
the first one is Creative Lab. There is gesture device.
So I'm not as familiar with the device. What I can say is it supports any device that implements the Windows pointer message model. So actually at the application level on Windows, it also is built on top of this pointer model. And so we'll support that through MS Gesture. But I don't know about that device in particular. Yeah, that's something that we are thinking about, but I don't have anything to share today. It's not supported. You can't use Connect on Windows for IE quite yet. So, yep.
Yeah, sort of a more specific question. What's the relationship between the different types of value in touch action and the way you handle pointer events in your code? So like, say I have a value of pan y, and then what's the result? Like, can I just not draw a horizontal line anymore in your demo, or how does that?
Yeah, so that if the browser decides it should pan in the y direction, then you're going to get a pointer cancel. You're not going to get the pointer input while you're moving in that direction. But if instead you move in the x direction or any other type of interaction that the browser decides shouldn't pan the page in the y direction, then you get pointer input for that data. Okay. And this is it's CSS, right? So I can have one rule on one element and one rule on another element. So even though the browser might have decided to start panning in the y-axis with this finger on this scroller over here, I can touch over here and on something that's touch action none and get pointer events for it.
Yeah, cool.
Yeah. Great. If you have more questions, follow me. I'll stick around. Thanks.